Changes. Don't wanna be a richer man. Changes. Turn and face the strange. Changes.
I have a quotient, don't I? Something divided by something. So I think I'm going to use the quotient rule to take the derivative. Now, in the process of taking the quotient rule, I might have to use the chain rule. Let's see. Here I go. Quotient rule. Low D high minus high D low, square the bottom and away we go. Or derivative of the top. So, oh, hey, I'm using the chain rule, aren't I?
I think you are.
So here I go. Derivative of the outside, so bringing that 4 down, times the innards to the 4 minus 1. And the innards are just 6x to the third minus 8x, times the derivative of the inside. So power rule, 3 times 6, 18x squared minus 8. So that's the derivative of the top times the bottom as it is, minus the top as it is, times the derivative of the bottom, which is just 2x. Did I do that all right?
Looks great.
Okay.
I know you
All
say
over.
innards, which, to me sounds...
Innards?
Yeah. I say inside. Innards sounds so like, visceral or something. I don't know.
All over the bottom squared. So, again, if Mr. Haas or I say take the derivative, don't simplify, this is it. You're done. You have taken the derivative. You've done the quotient rule using the chain rule in the process. But if we say simplify, we're going to try to simplify this. It's already one happy family, but we want to pull out common factors, see if anything divides, and we'll call it good. Here I go. The denominator, since that's just x squared, I feel confident that I can just say x to the 4th. All right? Now, I could multiply this all out and combine like terms and blah, 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 but that's crazy. Instead, I'm going to recognize that I have 2 big terms. First term, second term. Maybe those 2 terms have something in common. Let's go. Let's see. This has a 4, that has a 2, so I can factor out a 2. They both have a 2 in common. They both have a 6x to the third minus 8x. Looks like I can pull out 3 of those guys. Let's see. That doesn't look like it's in common. Oh, they both have an x in common. So that's what I'm pulling out of both. Let me put a big parenthesis to write the leftovers. I divided out a 2, so this 4 divides by 2 to give me a 2. I took out all of those, which is great. That guy is left. And I divided out an x, so I have 1 x left. So far, so good?
Looks good.
Minus, let's see, I factored out 3 of these, so I have 1 of those left. Times, let's see, I factored out a 2 and an x. Oh, good. So I'm done there. Oh my goodness, I'm running out of room.
Yeah, but you're getting there.
I'm getting there. All right, this, can I move that x next to the 2, just so it looks neater?
Absolutely.
2x times 6x to the third minus 8x quantity to the third. I'm going to do a normal parentheses here. So let's see, I have that 2 times that x, and I'm distributing that through. Can I just do this? 2x times 18x squared is going to be 36x to the third. 2x times negative 8, negative 16x, minus 6x to the third. Don't forget to distribute that negative, plus 8x.
It's looking good.
Looking good. All right. Can I whip this whole thing up here? Can you follow me, Mr. Wallace?
I got it.
Okay. You're very gifted at that.
Thank
I
you.
have x to the 4 on the bottom. You have 2 and x. This is all unchanged. Basically, I'm just trying to clean up that one factor. I have some like terms, 36x to the cubed and a minus 6x to the cubed, so that leaves me with 30x to the cubed. I have negative 16x plus 8x, so that's minus 8x. All right, and now this gets a little interesting. Am I done? Or are there some things I can divide out? Well, I see something that I could easily divide out. I have an x sitting there, and I have x to the fourth sitting down there. So I think I can safely say that x divided by that x to the fourth would leave me with x to the third. The other question is, do I have anything else? Let me just rewrite this. Is there anything else? I'm just rewriting this in a slightly different order. Is there anything else I can divide out? Well, looky here. Don't I have an x that I could factor out? This is getting kind of complicated, but I could factor out that x. And then, hey, now that's free to divide out. Now, if you're really thinking carefully, you actually can take this a step further. This ended up being a more complicated one than I was anticipating.
I would say if students have gotten to this point, we're calling it done.
We're calling it done.
But
Beautiful.
one could continue to simplify
Good.
for those who are as into it as we are.
Exactly. For
Probably
you
we're
overachievers.
talking about a lot of students now, I'm thinking.
So I think you're seeing what I'm seeing, Mr. Haas. Over here, there's an x in both those terms that I can factor out. So let's just look, and I'm feeling really constricted with space. Why don't we pause, and I'm just going to take this out. Here we have our derivative that's nicely simplified. And just to say again, we would consider this simplified, except for those of you who really want to be gung-ho.
Really hardcore simplifiers here. Yeah.
Hardcore simplifiers, because there really is an x lurking up here. There's actually an x cubed lurking up here. Let's look, shall we? If I look at this factor right here, I think you'll both, we'll all agree that there's an x that's common to both of those terms. So I could factor out an x, but keep in mind that everything in these parentheses is cubed. So I'm factoring out an x, but it's really an x cubed that I'm factoring out. Did I enunciate that enough?
I think you did.
So I factored out an x, but if I'm taking it out of those parentheses, it's really an x cubed. That's a little funky. And now I think you'll see where I'm going. Now I've got an x cubed divided by x squared. And this whole shebang ends up being a nice expression, 2x. I just moved that x over there. Woo, I'm getting so excited I flipped that marker. 30x squared minus 8. Don't try this at home, people. 6x squared minus 8 all to the third. And there we have our uber simplified function.
That's great. And you know, like next year, when you're taking AP Calc, you might be asked to take the second derivative of a function like that original function, and then, man, if you don't simplify all the way, it's going to be a lot rougher. So
I'm so glad you mentioned that, because that's exactly why this is handy. When you have to take a second derivative, you don't want to take the second derivative, that big ugly
No,
thing
that's
that we
crazy.
started with. You want to have it in a much more manageable form.
Changes and face the strain.
Changes. Don't tell them to grow up.